Hi, I'm Tim Studd. I'm the editor-in-chief of Laboratory Equipment Magazine, and we're here at PittCon 2011 in Atlanta, and we're at the IDEX Health and Science booth, and we're with Caitlin and with Eric, and they're going to explain some stuff about their products and their services. And Caitlin, we'll start with you. A number of companies are exhibiting reusable fittings this year for UHPLC, and what's driving this, Caitlin?
That's an interesting question, and it actually reminds me of when HPLC first came out. The fittings that were all used in HPLC were stainless steel swage connections, and they basically look like this. Then eventually, Upchurch Scientific came out with an all-peak reusable fitting that was much easier to use, and it could be used on multiple tubes. Once you tightened it down, you could actually loosen it and put a new fitting in. It was something that had a lot of appeal for chromatographers. And once pressure started rising in the last few years up to 15,000 psi and more, the trend was to go back to the standard swage fittings because those were the ones that were able to withstand this high pressure. The peak fittings, the reusable fittings that were currently on the market were maxed out at 6,000 psi, and then the tube would actually fly out of them, which made them not a good, safe, reliable option for the UHPLC systems. But just this year, as Tim mentioned, many companies have come out with reusable fittings, including IDEX Health and Science. This is an example of the reusable fitting that we offer. It has a polymer front ferrule, and it can be used up to 10 times in different ports.
Okay, Eric, what are the issues in reliability associated with fittings for UHPLC?
Most of the issues with reliability all stem from the increased and elevated pressure. So what happens is the X dimension, that distance from the end of the front ferrule to the bottom of the port, that dimension needs to be stepped by the ferrule. If it slides back, it creates dispersion, which then creates band broadening, and the chromatography results. So much of that has to do with that X dimension and being able to set that at that elevated pressure.
Okay, and how did you go about proving reliability?
So first we started out with just pressure testing, understanding that at this elevated pressure we're capable of maintaining that seal so that X dimension is not changing. So by going to elevated pressures, our test stand actually goes to 45,000 psi, and basically we would tighten a fitting into a port and then verify what pressure it was capable of. So once we had that information, we then looked at doing chromatography studies. We did both isocratic and gradient studies. For the isocratic, we did over 8,000 injections, repeat injections. For the gradient, we did over 2,000 injections, and we're just trying to verify that there's no dispersion, no band broadening, or any negative effects from the fitting itself. There's a great deal of information already out there on those permanent connections, and so what we're really trying to do is to do a comparison study between that permanent connection and the new reusable connection so that everyone's comfortable with this style of fitting.
Okay. Caitlin, what does all this development and testing data tell us?
Well, basically, we're able, through the testing that Eric just described, to prove that the new reusable fittings are equivalent in performance to the standard traditional swage tubing and fittings that you have been seeing on the UHPLC systems today. So we have a wide variety of these types of connectors available for different thread sizes, different tubing sizes. We have a new line also of filters that work in a similar way and are able to be reused on different tubes. And we have a unique line of torque tools in order to facilitate tightening of these fittings into ports.
All right. Thank you, Caitlin. Thank you, Garrett.